Okay, today I'm going to go through our lesson 5. Not a lot of new information, but some important information. We're going to go over mixed data types, which we've already actually been doing. But the new things we're going to do is learn about something called casting and constants. So as we have seen in calculations, we will look at what happens when we mix ints and doubles in calculation. So I have some information here in memory on the side like I've done in the past. Here, show we might lose something called precision. Another word for precision is accuracy. So suppose I have a variable d, that's a double, that's 29.78, and I should have a semicolon here. And then I try to do something like this, int I equals d. So looking over here at memory, remember doubles take up a lot more memory than integers. So it's like I'm trying to take something this big and put it in a memory location this big. So that is not going to work. You're going to get a compiling error. Now, continuing on, here's where we won't lose information or lose precision. So let's say I declare an integer variable t, so I have a small location here, and then I assign t the integer part of the variable d. So this operation here is called casting. So let's talk about what casting is. So what casting is a Java process where we convert from one type of number to another. In this case, we are telling Java to give me only the integer part of the number and throw away the decimal part. So recall that we know that d is set to 29.78. And this operation is saying, hey, just give me the integer part of d, which happens to be 29. So then in memory, we see that t is set equal to 29. That is called casting. We are only telling Java to give me the integer part of the number and throw the decimal part away. So how do we cast? Well, inside of parentheses, we put what type we want the number to turn into. So in our case, we wanted our number d to turn into an integer. And on the right, we either put the variable or we could just put a number itself. Now, moving on, we can do something called promote an int to a double, and we have seen that. So for example, double c, and then I set c equal to the value of t. So when I come back here, I grab this integer that's t is equal to 29. I'm assigning it to a double or a decimal, so that turns that value into 29.0, or 29.0 is assigned to the value of c. Now, an important concept in Java is something called a constant. This is a number that's not going to change once you set it. This will use a new reserved word, final, so that will show up purple in JGrasp. Once you set a constant, if you attempt to change the value of the constant after its value has been set, you'll get a compiling error. And we'll see that in demo tomorrow. Now, a Java norm is that names of constants are all capitalized. So let's look at some examples. I've given you an example of an integer constant, a double constant, and a string constant. Notice that they all start with the keyword final, then the type of the variable, and then here are the variable names. And again, they're all capitalized. So num days is 365, perhaps the number of days in the year. Pi is a number, a constant, a decimal constant we know from mathematics. And finally, here might be a constant for the name of our school, DCMST. Now notice here, I have the ... operation. Later on, if I try to change the value of a constant, that is not allowed, and I will get a compiling error. Another important thing to make sure you understand is the difference between concatenation versus calculation. If we concatenate a string to or with a bunch of numbers, all that does is smash together the string with the numbers. So if I have SOPLN, a string, concatenated with 1, concatenated with 2, concatenated with 3, when I run this, it's going to print hello 1, 2, 3. Now, if I actually want to force a calculation like adding those numbers 1 plus 2 plus 3 and then concatenating with a string, you have to use parentheses to force the calculation. So if you move down here, we see I'm using parentheses to force the calculation. 1 plus 2 plus 3 is 6. So if I take this string, sum equals, and concatenate it with this operation, which is now a math operation in parentheses, what it will print is sum equals 6. Now below, notice how I've changed this up. I only concatenated 1 plus 2, this operation, which is equal to 3 in parentheses, and then I concatenated it with 3. So what gets printed again is sum equals, the answer 3, concatenated with another 3. So I'm going to be demoing this quite a bit tomorrow so that you understand the difference. Now that you know what casting is, and then this might be a little hard for us to see. I might have to move this around some. So let's say the last thing I want to talk about is compound operators. So let's assume in this example that J is an integer. We learned last time that we can have this shortcut operation J plus equals X. And we know that means J equals J plus X. For all compound operators, there is an implied cast. In other words, if I have J plus equals X, what this is really saying is J must be the integer part of J plus X. We have no idea what X could be, and you can see at the bottom of the notes that that is the case. And I'm going to demo this tomorrow. So sadly, I really can't see that part of my notes, and I don't really see a way to do that right now. Oh, here we go. So if we have J plus equals X, we know that means J equals J plus X. But what that's really saying is, again, take the integer part of J plus X. So what I'm going to demo tomorrow in class is if I say J plus equals something like 2.713, what's going to happen, and assume J is 5, it's going to take the integer part of 5 plus 2.713, which is just going to be 7. So this will make a little more sense tomorrow. But for right now, I just want you to write that down. And that's all I have for you today. Have a good night.